And here's something unusual that I will get you to do. You might think there's something wrong with this, but remember SOHCAHTOA from grade 11? Vaguely, sine, cosine, tan, okay? We're not going to use those trig ratios anymore. So you take the first two pages, the first two sheets, okay? And you want to see this working with the sine law. So you will rip this out. So that's going to be your front page. So this, you can chuck it, okay? I'll take it out next time. Just get rid of it. So you can call this at the top chapter 7. Okay? Because I used to review SOHCAHTOA, but it doesn't come back, so a lot of students would mix them up with the new trig. I call this new trig, okay? Also, grab your calculators and make sure whatever you're using is set to degrees, okay? So you should have a little D or DEG for degrees. If you don't have that, there are a couple of ways of changing that. You either press mode. For my calculator, I'd have to press mode and then mode again, and it's degrees, right? Some of you have a DRG button, so you just keep pressing that button until you start seeing a D there for degrees, or DEG, right? So you want to make sure that is there, or else everything will be off. All your answers will be off, okay? So it's terrible. I can't get it right here, but and if you're using a cell phone, which I would not recommend, but for today you might have to. So there's my calculator, right? So if you hold it this way, it's just a regular calculator. You turn it sideways, it should look like this. And at the bottom here, at the bottom corner, this is an iPhone. Sorry, Android folks, I don't have. So rad, that's for radians. So if you press that, you will see radians on there. You don't want radians, you want degrees. So you press the degree button again, and then nothing should show up. So this is what you should see, okay? And I will show you how to use this. It's different, it's more complicated, but it can be done, right? Okay, so we're gonna skip down to the bottom half here, and I will just highlight sine law, right? That's new. Couple of things to highlight here. Trig ratios such as sine, cosine, tangent, as well as the Pythagorean theorem can solve for the missing side lengths or angles of right triangles, right? But what happens if you want to know the missing measurements of an oblique triangle? An oblique triangle is a triangle without a right angle. So anything that isn't a right triangle is called an oblique. So you can highlight the oblique part here if you want. And we're going to only study the sine law and the cosine law. There's no such thing as a tangent law. You rip the first two sheets until you see this. So this is page 260. Okay, Marcus, I got you. So chapter 7, sine law, okay? And I want you to highlight sine law again. And the sine law states, right, that you can use it in oblique triangles in certain situations. And this is true. Okay. And I want to make a note because a lot of students don't think it's true. I will say also works with right triangles though. That's the beauty of this. It works for all cases, right? It also works for right triangles. Okay. Now, notice what the sine law is saying. That the sine of angle A, so angle capitals are always used for angles and lowercase side are used for sides, and they're always across each other. Okay, notice that? That's basic labeling from grade 10 probably, right? So sine A over side A is the same thing as sine B over side B, sine of angle C over side C. So notice that they're always in pairs like that. That's crucial, okay? You can write it like this, or you could also write it like this. A over sine A is equal to B over sine B is equal to C over sine C. Okay? It's important that you know that they're both, you could have the side lengths on top, or you could have the side lengths at the bottom. Okay? Also note this. Uppercase denotes angles. You could have A or angle A. It doesn't matter. Sometimes they just use a capital. Sometimes they have that angle symbol in front of it. Lowercase denotes side lengths. Also note that angle A is across side A. Right? Always. Couple more things. Sum of the angles in a triangle is always equal to 180. And I'm sure you recall that. So example, how do we use this? How do we use that? Well, if you have a triangle, let's say that goes like this, not drawn to scale. None of your triangles is ever going to be drawn to scale in this chapter. So let's say you have two angles out of the three given. Right? Then you can easily find that third one by just simply going 180 minus 80 plus 70. Okay? Like if you add the two and you subtract that from 180, then you're left with essentially 150. So that third angle must be 30 degrees. So that's very important. Some students forget that. Okay. So I'll box this in a little bit because I will give you more so that it's like one idea boxed in, right? Equilateral triangle means that all sides and all angles are congruent. What does congruent mean? It's just equal. It's another fancy word for equal. So if you have ABC like this, when you see the markings like that, that tells you that these three sides are exactly the same. And they would have markings in the angles with two lines like this, indicating that these three are also the same. Angle A is equal to angle B is equal to angle C, which is always equal to 60 degrees. You know for a fact, it doesn't matter if it's a big or a small triangle, that this is always true. All three angles will always be 60 because you're splitting 180 in 3, right? So 3 times 6 is 180. So that's equilateral there. And then you have an isosceles. Isosceles triangle. You have two sides and two angles that are congruent. And the key here is to remember that, let's say these two sides are the same. It's these two that we're talking about. Then it's the angles that are across from those two sides that are the same. So let's say, for instance, that the top angle here is 70 degrees, this one, right up here. How would you find these two? Well, because we know they're the same, we can use the following reasoning. Okay, angle A would be 180 minus 70 divided by 2. Because if you take the 70 away from 180, right, you split that difference in half because you know that they're both the same. So it's 110 over 2, which is 55 degrees. Angle A is equal to angle B, which is 55 degrees. Take a moment to write that down. So those of you who joined a little later, group 2 is up for coming in on Monday, October 5th, okay? All right, so we're gonna go to page 261 now, okay? And we're gonna apply this. So I'm going to bring this down here. And one thing I want you to remember when using the sine law, okay? So it says use the sine law, which will not always be, they won't tell you which law to use down the road. But in this case, use the sine law to calculate the length of side A. So they want this one here. This is our unknown. okay? And I want you to remember this. And using the sine law, you need a known angle side pair, and you will know what I'm talking about in a bit. You need to know an angle side pair. Okay, so what do I mean by that? Okay, I'm asking you to find a pair like this, right? You know the angle, you know the side length. This is what I call with pair. This is the pair, known pair. Because think about it, you don't have anything here. C, you absolutely know nothing about C, right? So this is your pair, and that's what you start with every time, okay? So watch this. The equation would say that sine of 52 degrees would have to be over 6.8 centimeters. Okay, you always put them as a pair, okay? Does it matter if 16.8 goes on top and the sine of 52? No, but it does matter that these two are on top of each other, okay? Is equal to, they're asking us for side length A, correct? You know what sine of A is, which is, you know this angle. So you need to put down sine of 72 degrees. And this is going to be our unknown. This is going to be side A there. Just be very careful, okay? Let's say this is like this is exam time and you're writing the exam. I see a lot of students at that point forgetting the sine. They just put down 72. You have to have sine, that the angle has to be coupled with sine, okay? The side length is flying solo, but the angle always needs a sine, okay? So this looks like a proportion. We cross multiply and divide. Cross, multiply, and divide, which we've done so many times by now, right? So watch, I want you to show me the work though. A is going to be equal to 16.8 times sine of 72. Just write this down for now, and then I'll walk you through how to use your calculator. Divided by sine of 52. I always write down the value in front of sine. I don't, even though you could flip them, I prefer to have it in front just so there's no issues with 72 and 16.8. You kind of split them up with the sign, and that's what you get. Now watch what I do. So you go 16.8 times sine of 72 equals, that's what I do. And then I go divided by sine of 52. And that's 20.28. Okay. I'm just going to go one more line here. A is 20.28, and we are in centimeters. If you go back, sides are in centimeters. So there. That's how you do it. And I will add to this question. So let's make this a B. Calculate the length of side C. Write that down at the bottom, like just set bottom half of this page, right? Let's quickly copy this down, the triangle that we're given up there. It's not that hard. Start at the top, so it's A, B, C. This is 52. This is 16.8. C and C. A we now know is 20.28. And this is 72 up here. So I basically just copied down, and now that we found out this, I can have that there, right? The key here is that if I wanted to find side C, if I even want a chance to get it, what do I need? I would need to know this, right? So need angle C. Right? So notice that C, right, is the third angle missing. We have 2. So angle C is going to be 180 minus, I will do this slightly differently than what I showed you earlier. You just keep on subtracting the 2 that are there. So angle C is going to be 56 degrees. And watch what I'm going to do here. I will suggest you do this every time. Notice that now you have this pair here, and you also have this pair here. I would not suggest you use this pair, the new pair, because if you made a mistake here, it will carry forward. I would stick with this one, the one you used earlier. So I would go sine of 52 over 16.8 is equal to, now you're going to put sine of 56 in here, right? Because you want 56. Since 56 is located here, you put side C down here, because that is this is technically, they're across each other. And notice that I have angle and angle, side and side. Okay, so here you would cross multiply that way and divide by that. So C is 16.8 times sine of 56 over sine of 52. And this one I might actually do with a cell phone as well, so you see it, right? If you're stuck with a cell phone today, I will show you how that's done. It's 17.67. Round it. Where's my phone? I'm going to try this. Okay. So if this is what you're stuck with, I would do this first. I find what this is, I multiply it by that, and then I divide it. So this is what you need to do. 56 sine, that gives you the value for sine of 56, times 16.8. You get what's up top now. Watch this. This is where it gets tricky. Divided by 52 sine, and then press equal one more time, because right now you're just seeing what sine of 52 is. It equals. And so that's where you get the same as me, right? 1767. So that's the trick there, which is on video, so you can check it. One more thing. Let's go back and fill in everything that we just found to the original. This one we found is 56 degrees. This one we found was 20.28 centimeters. And this we found is 17.67 centimeters. And I'll tell you a little fact, right? Largest angle is across longest side. Always. Largest angle should be across the longest side. Smallest angle across shortest side. If this isn't news to you, then maybe don't write it down if you don't want to, but that's how I check. Which one is your largest angle in this triangle at 72, and the longest side is across from it? The second biggest angle is this, which is 17.67, which is slightly bigger than the smallest angle side, which is across the smallest side, right? So that's how you check. Okay, so now I'm going to ask you to go to 262, so next page, and give it a try. Get your feet wet, okay? Worst case scenario, you get it all wrong, big deal. So maybe you do yours on the left side, and then I'll do the corrections on the right side of each triangle. So there's 3 triangles there. I see that our time is running out. Right, so here I have a pair, known pair, right? So you start with that. Sine goes with the angle, like that. And on the other side, what are you trying to find? You're finding this guy. So you want the angle that's across from the side you're trying to find to show up here. Okay? If they had given you this angle and you put that angle up here, you're actually finding this side. Okay, so you gotta watch out for that. So you cross multiply here. So for most of you, it's just see if I got it right. And that's 624.91 meters. Right. I asked you to solve, so I'm going to do the solving part on this side. So the next step would be to find angle x, right? And that'd be 180 minus 132 minus 15. So you get 33 degrees, so that's part of it, right? So we've now found that third angle using the property of sum of 180, right? Now I'm going to start with the same pair that I already know. Right? And on this side, I'm going to now put sine of 33. Because remember, that's that angle right there. So you're going to find angle x, right? So x is there. You cross multiply that way. Sine of 132. And that gives you, because I'm running out of room, 15.01 meters. I'm just going to check once. This is the second largest angle, and it's slightly bigger, or slightly, but it is bigger than the other side, which is across the smallest angle, so it's okay, right? And it's not bigger than the longest side, so you're kind of checking if it's between the two sides that you already know. Okay, so next would be, where's my pair? Oh, it's right here. Okay, if you have a pair, it is sine law, guys. It is sine law, because we're going to do cosine law later on. Okay, so sine of 61 over 15.9. I'm trying to find this side, so I'm going to grab the angle on the other side. And this is side M. So that's 15.9 times sine of 43 over sine of 61. So M is going to be 12.40. And I'm just in the habit of writing down 2 decimals so that I don't forget. Right? So over here, I'm going to find that third angle, angle L, and that's 180 minus 43 minus 61. L is 76 degrees. So now I'm going to start with the same pair that I started with here. Okay, sine of 61 over 15.9 is equal to sine of 76 now, which is this guy, right? So I'm going to find lowercase l. Over sine of 61. And when I do that, I get 17.64 centimeters. Right, for side L. So just keep in mind, right, is the angle that I'm grabbing, is it across the side that I'm trying to find? Because if you grab this one, you're actually finding the side across from it, right? So that's the key here to remember. So two things, that these two are across each other, that you always have sine next to the angle, and perhaps also make sure that angles, right, the sines are this way lined up and the side lengths should be, you can't flip-flop as you please, okay? Okay, so next. So this one was a little trickier because right from the get-go, they ask you to find this side. You look across from it, you don't even have the angle here. So that's done on purpose, okay? So you need to find this angle first, and you have two given to you, so it's easy to find. So that would be an extra step, right? You need angle P, right? So angle P is 180 minus 40 minus 34. Oh, by the way, do you have a pair? Yes, you do have a pair here. So you know it's sine law, you just need to do a little bit of extra work. And P is 106, which is an obtuse, right? Obtuse angle. Not that it matters, but you need to know, right? It's bigger than 90, so it's obtuse. So now we start. Start with my pair. And angle P is right here, so sine of 106 over side P, 36.3. Notice that the angles will later have decimals. That does not change anything. Stays the same. So P is 54.29 centimeters. And this one is a little easier because what do we still need to find? We need to find R, right? If you want all of it. So sine of 40 over 36.3. Sine of 34 will have side R across from it. So you cross multiply this way. And notice that it's the smallest angle, so we're expecting the shortest side out of this one. And I don't have this, so I'm going to have to calculate that. Okay. So that's 31.58. Notice this. I'm going to say it because it happens every year at least once. You cannot use the Pythagorean theorem because none of these will be 90-degree triangles. Very few, like I don't think you will get one. So you cannot use the Pythagorean theorem because some students are like, oh, I've got two sides, I'm just going to go c squared equals a squared plus b squared. No, you can't do that, right? It's not a right triangle. Don't use regular SOHCAHTOA. Some of you probably still remember That's why I made you rip those out. I'm not even reviewing it because then you want to use that sometimes because you've done it so long, right? So those are a few things to watch out for. Okay. So I'm just going to show you how to do angles as well. So all of these were side lengths. Okay. We're going to do one example of how to do angles. It's a little different, but the setup is exactly the same. Okay. So let's go to page 263. So I'm going to put at the top here, I always like to have a little title there. So solving. And this is sine law. Okay, don't forget we're still only doing sine law right now. So at the top you should put down, this is where I show how to solve for an angle. Study sheet is actually fairly simple. Maybe go to the very beginning and just write down the formula and maybe how the triangles are labeled and maybe one example, right? One example of how you solve the triangle. Here it says calculate the size of angle. This is angles A and angle C. So they essentially want this and they want that. Okay. Do you have a pair? Angle, you go across, you know the side. So yes, you have your pair. So because it's a pair, we know it's sine law. Why am I saying this? Because down the road, you're going to have to choose which one. And pair is sine law, guaranteed. Okay. However, sometimes the pair is a little hidden. Okay, I'll tell you what I mean by that. Let me just go back one more time because it's important that you know that it's hidden. We don't have an example here. Okay, it will come up. You'll see what I mean in a bit. So we had a pair there. So let's start our setup just like we used to do. Okay, I'm going to go further to the left here because then we'll use the right side. Okay, so almost just split it up here somewhere. So we're going to go sine of 81 degrees over 123.2 is equal to, and which one should you find first? If you go sine of C, you would have to put the side length underneath. If you did that, you would have two unknowns on this side, which is not good. You can't solve it. But if you solve for A first, you do have the side length, right? So we're going to solve for A first, sine A. So no degrees now. You put a capital letter for whatever is there, right? And then you put 91.6 underneath it. I will make a note here. Can't solve for angle C yet, okay? In case you're wondering, why didn't you do C first? You can't. There's too much unknown there. And if you're tempted, if you set it up, you'll see what I mean. So this is basically your variable. So the ones you can cross multiply are these two. So you write down sine of A, the whole thing, sine of A, okay, not just A, is equal to 91.6 times sine of 81. Okay, so you multiply these and you divide by what's left, so that's the same. One more line. We're going to write down what this is, and I can guarantee you, okay, it's 0 point something. If you don't, you made a mistake. Guaranteed 0 point something. I will say that again. If you don't get 0 point something, you made a mistake. Okay. So 91.6 times sine of 81 equals divided by 123.2. And it's 0.7343. Okay. I use all decimals here, folks. So what I do is I just write down 7343 and I go like this, dot, 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 meaning I'm going to use all decimals. And this is the kicker here. To find angle A, to get rid of that sine, we have to take sine inverse of this. And I will show you what it looks complicated on paper, but it's actually not that complicated if you have a decent calculator. Watch what I'm going to do. I still have this number in there. So all I do is I press shift. You might have like a second or something like that button, and then press sine because it's sine, right? The inverse of sine. Because watch, above sine there's a sine inverse with a -1. You press that and I hit equal, and my calculator takes that answer that I had before and already plugs it in. So it's 47.25 degrees. The province always wants you to have 2 decimals. So let's say you don't have a calculator like me and you can't do that, right? What you do is you write down 4 decimals here, just like I did. And so if you go shift sine and you type it in 0.7343, you should get almost, if it still rounds to 0.25, okay? It still does. So now that we have this, we can find C because 2 out of 3 gives you that third one, right? So angle C is simply going to be 180 minus 81 minus 47.25. So that's 51.75. And before I leave, I'm just going to have one more thing here, okay? This is going to be the last thing we do, okay? Draw a triangle. If I give you this, would you be able to draw a triangle? It doesn't have to be the scale. Okay. The only thing that I notice out of the 3 angles is that there's one that's 100 degrees, so it's a little bit bigger than 90. So I'm going to draw my triangle like this. But if you didn't, I don't think I would mind. Okay? So I will say this is my 100-degree angle, and the side across from it is 3.2 meters. Right? Then you go to the next one, 37. You choose which one, 37, and the side across from that would be 1.9 meters. And obviously 43 is here, making this 2.8 meters. I would not expect you to draw it to scale. I'm just looking for can you look at this and see that it's a triangle that just has those two across each other? And I will, just for fun, give letters to it, right? So A, B, C. And just so you know, angle A could be referred to as angle BAC. I don't know why they do that complicated, but angle A could also be referred to as CAB, angle CAB. But notice that both times it's in the middle. So notice that the angle in question is in the middle, and it's just telling you which 3 points make up this angle. Okay, this is an important notation, right? Watch out for that notation. That's it, folks. If you're home, you can log off. Have a good weekend. Everybody here, have a good